an array for NoSQL. Basically the start of the page for NoSQL.
Oh, an array for the data.
Until the NoSQL part. So basically each paragraph you can start scrolling. Each paragraph is by paragraph. Okay. Thank you, Yongyu. For NoSQL question 10, we used a similar logic to MySQL by matching total cases to be more than 50, then grouping by location and total cases, and push the dates as documents into an array for the dates where the country had the same number of cases. Then we counted the number of days in the array, and those with a count of more than 14 are the countries which have achieved more than 14 days of 0 new cases. For NoSQL question 11, we built on this query. Using the last date of the constant total cases, we added 7 days to the date and 50 to the total cases on that day and performed a lookup pipeline on the same collection for those which had an increment of more than 50 in total cases within the 7 days period. For question 12, generally, looking at the highest changes showed that most places experienced a drop in mobility with negative change from baseline values except for parks and residential areas. For the approach of how we retrieve this from MySQL, for each category, an inner subquery was performed to retrieve the top 3 countries and their respective highest absolute baseline changes after filtering out the subregion 1, 2, and metro area. Then, this subquery was used to inner join with the global mobility report on both country and the absolute change from baseline. This will give us the rows where the actual values match the absolute values of each country, sorted by the magnitude. From there, a second group by is performed in the outer query such that the same country will be grouped together with the highest absolute and actual value for their baseline change. Then, we limit the query to 3 again to show the top 3 countries and their actual baseline change, and use union to combine the queries for all categories. For the NoSQL approach, we looked for the data for the whole country for each category. Afterwards, we projected the absolute change and the actual change. From there, we grouped by country and date before sorting by the absolute change to ensure that the documents are ordered in a decreasing order of magnitude. Afterwards, we performed a group by of the country again, taking the very first absolute and actual change values, as they will be the ones largest in magnitude. Afterwards, we sort them again to project the countries with the highest baseline changes and their actual values. Using a union operator, we combine the same query for each of the categories into a single query. For question 13, before D-Day, there was an increasing trend in grocery and pharmacy mobility, which quickly plunged right after D-Day when 20,000 total cases were recorded, before slowly returning to normal. For retail mobility changes, before D-Day, it was on a steadily increasing trend before a steep plunge. Afterwards, retail mobility was steadily increasing again. For workplace mobility changes, there was a constant high fluctuation in mobility throughout the period analyzed. Especially after D-Day, there was a steep drop to negative 70%, which quickly increased again before fluctuating. Overall, only retail, grocery, and pharmacy showed meaningful trends in mobility before and after D-Day. For the MySQL approach, we performed an inner subquery to look for D-Day, which is the first day when Indonesia crossed 20,000 total cases. This subquery was used in a where clause twice to look for the interval of 14 days before and after D-Day. From this set of conditions, we found the date and the respective baseline changes of the 3 place categories in Indonesia for a total of 29 days. For the NoSQL approach, it is like the MySQL approach, except that we use a lookup pipeline instead to find the mobility changes for the period before and after. Now, Jingzhou will be talking about the relational versus non-relational database.
I feel like my saliva